So my name is Jeff Schwartz. I work for Blue Coat Systems. I run our service provider business for the East Coast of the United States and Eastern Canada. Before I get started, has anybody heard of Blue Coat before? Does anybody have any Blue Coat technology that they're using today? Packeteer. So we acquired Packeteer about 3 years ago, and that's actually pretty pervasive within the education sector. Okay. What about caching? Anybody have any experience with web caching technologies? Okay, so all right, so we have some familiarity with Blue Coat, some familiarity with Blue Coat with caching. My focus here today is really to walk you through a trend that's taking place in the service provider market around web caching. Web caching was pervasive back in the late 1990s, and it's actually coming back into vogue. And there's some really key benefits around caching technology that I'm going to walk you through. This is going to be more of a sales and marketing-oriented presentation. I have some technical skills, but not a tremendous amount. So I know the last presenter was extremely technical. So if you do have technical questions, please raise them. I'll address them to the best of my ability. If for some reason I cannot, we can table it, and we can have one of my engineers kind of follow up. Okay? So let me just quickly walk through. Let's see here. The agenda. I'm going to talk quickly about some of the market trends that we're seeing in the marketplace. Talk a little bit about the different use cases around caching and how it's becoming back in vogue relative to it being in vogue back in the late 90s. And then I'm going to talk about Blue Coat's CacheFlow technology. So again, some of you that know Blue Coat know us probably from being a web security leader, WAN optimization, the packet shaper technology, which is around bandwidth optimization and bandwidth management. Web caching actually was where Blue Coat got our start back in 1996 under the brand name of CacheFlow. So from a historical standpoint, our roots actually are within web caching technology. Given some of the trends that I'm going to talk about here in just a minute, you'll see why we're getting back into that segment of the marketplace. So let's really quickly jump into some of the trends that we're seeing in the marketplace. So the first is around broadband subscriptions relative to downstream bandwidth. The bottom line here shows the broadband growth over the next 3 years. The line right here talks about downstream bandwidth growth over the next 3 years. And I think the key message here is the downstream bandwidth growth is far surpassing the growth in broadband subscribers. So fixed line subscribers, there's a tremendous amount of data on the network. This is a good testament to the fact that downstream bandwidth is growing at a much faster clip than subscribers. Okay? And again, a lot of what I'm going to talk about in terms of market trends is how the networks are being taxed today. And it's going to be a good setup when we talk about where web caching fits into the networking infrastructure. Okay? The next trend is around mobile data. I think everybody probably has a mobile device or multiple mobile devices. In 2010, mobile data traffic grew almost 3x, and it's going to consistently double and triple over the next 5 years, as predicted by a lot of different technology companies, including Cisco. There's 5.3 billion wireless subscribers, a lot of petabytes of data per month. 50% of mobile data is video. So I think what we're starting to see is obviously video is becoming a major consumption of network traffic. And that number is going to grow probably closely to 60, 70% in the next couple of years. The downstream speeds are speeding up. So I think really the message again here is not only on the fixed side, but the mobile data explosion is underway. Over the next 3 to 4 years, you're going to consistently see more mobile devices, more tablets, and more people using mobile devices as a means to either conduct their work or as a means of to do their recreational type stuff on the web. And this is going to be a key catalyst for these networks, again, to continue to get consumed with a lot of data. And that's where, again, where web caching is going to come into play. So this is a chart from Telegeography. This is a global figures. So this is not necessarily representative of Canada, which is going to be a little bit different. But in general, all of the traffic that's traversing the ISP networks today, about 60% of it is port 80 or HTTP traffic. In the US, we're seeing that number to be closer to 70, 80%. In Canada, it's probably around 70% from all the ISPs that I've talked to in this region and in Toronto. Of the web traffic that we're seeing out there, this is the browsing traffic, video streaming, file sharing, which really is represented by the red, navy, and yellow here on the pie chart. Netflix is accounting for roughly 20 to 50% of all web traffic. And that's really primarily a US number. In the US, we're seeing about 25 to 30%. Here in Canada, obviously there is not, Netflix came a little bit later to this particular market. I think it's been in market for just over a year now. But we're seeing an uptick, even Netflix in this market. And I think the point here is, as you look at the networks and as you're starting to manage your networks and trying to plan for the future capacity growth within your networks, companies like Netflix, which didn't exist a couple years ago, are going to come online and they're going to quickly become 5–10% of your network capacity, and really making sure that you plan for really the capacity growth that you're going to have within your networks are going to be extremely important. It's Netflix today, but it could be Amazon tomorrow. It could be Redbox the next day. A company called Vudu is a new live streaming company that's coming out and about. And really being able to plan appropriately is going to be really important. Okay. 2 more charts on the trends, and then we'll move on. This is just kind of an overview of, again, the video flood. Are you guys seeing within the networks that you're working with today lots of video traffic? Do you have visibility into the networks today that you're managing? I mean, do you get this type of visibility into seeing what % of the traffic is actually video traffic?
It's all mixed up in port 80.
But a majority of it, I'm assuming, is port 80. Yep. Okay. So video is going to be the catalyst for that growth to continue. And this is, again, just some statistics. Web video is 40% of consumer traffic. That number is going to be about 60% in 2015, according to forecasts by Cisco. 3 billion YouTube videos per day and growing. Facebook is the 2nd largest video site in North America. And again, I think what's important here, you look 5 years ago, Facebook practically didn't exist on the network, and today it's the 2nd largest video site. And as I mentioned earlier, Netflix just a couple years ago didn't exist on the Canada networks. Now there's over 1 million subscribers that are actually subscribing to Netflix in Canada alone. So you're going to see the phenomenon of video continue. You're going to see more video streaming providers coming online that are going to continue to tax networks. And really planning and architecting your network now is really important as you look out over the next 12 to 18 to 24 months. Okay? So this is a webinar that Blue Coat did in concert with a company called Light Reading. We had about 200 individuals attend this webinar. And this is really just feedback for you and some intelligence for you based on what ISPs, both in the US and Canada, responded to based on a survey we put up. So in terms of improving user experience, almost half of the attendees were looking to improve their user experience on the internet. About 42% saw an overload of Web 2.0 and video. About 25% had high bandwidth costs, and about 13% had a strategy to deploy content delivery networks. So is everybody familiar with CDNs in this audience? The Akamais of the world, the Limelights, and so on? Yes? No? Yes? Okay. Okay. So that's it on the trends. Any question on that? It's sort of a setup to kind of some of the benefits that caching can deliver. Any questions on the market trends? No? All right, let's keep moving. So now I'm going to get into why caching. There are a number of use cases why internet service providers, universities are deploying web caching today, and that's really what I'm going to talk about in the next couple of charts here. Excuse me one sec. So the first is around bandwidth savings. Depending on where you're located within the country, oftentimes ISPs and universities have fairly high costs associated with the upstream internet capacity that they need to pay on a monthly basis. There has been a clear use case for putting web caching inside of the network to cache the content, to reduce the amount of content that's leaving the network, which directly reduces your bandwidth costs. Okay. The other way to look at it is if you have a 1 gig pipe today to one of your internet service providers, if you're planning now and you see that there's growth and you need to get to 2 gig or 3 gig, by putting web caching in today, you may be able to actually delay that upstream capacity upgrade by anywhere from 12 to 24 months. And there's some significant savings that come into play by delaying those capacity upgrades. Okay? And that's really, I think, one of the key use cases that we see around web caching is putting caching inside of the network, caching the content locally on the network, reducing the amount of content that's leaving the network, which provides real-world ROI and bandwidth savings, as we like to refer to it as. Okay, any questions on that? Okay, the next use case is around quality of experience. So I talked about this a little bit, and we saw it up on the webinar that I showed you. About half the correspondents did state that they had issues around quality of experience. So with this influx of video, with all the trends that we talked about a little bit earlier, that I talked about a little bit earlier, what we're seeing is a lot of internet service providers and a lot of universities are struggling with performance. How do they deliver better quality of experience to their user community? So another use case of caching that we've seen is utilizing caching to improve user experience, which will obviously aid in your customer satisfaction, create more of loyalty, and reducing subscriber churn. Okay? And effectively, what you're doing is putting caching inside the network, caching the content closer to the user, so when the user request comes in, the response is quicker than going back to the content origination source, which could be miles, hundreds of miles, thousands of miles away. So it provides a much high reduction in latency in terms of where the content originates. And that's another use case of caching. And these are two Blue Coat customers that actually deployed our caching technology solely for the improvement in user experience. Okay. The last one is around analytics. So again, having a device in your network where you can actually get good visibility into the domains that your users are accessing oftentimes is valuable for whether you have a marketing department or you want to get a sense of how students are using the content or how staff are using the content. You can get real good granular visibility into the reporting of the type of domains that your users are accessing. So this is a third use case. Oftentimes, our customer base is not buying caching for this sole reason. This is a value add that they get along with having caching. Okay? So these are the three kind of core use cases that we see around why ISPs, universities are deploying web caching today. Any questions on the use cases? Okay. So now I'm just going to talk a little bit about the Blue Coat caching solution, and we'll get into that, and that'll be the last portion of the presentation. Excuse me. So this is just a little background on Blue Coat. I mentioned earlier, we've got 15 years engineering invested in proxy cache. So as I mentioned, in 1996, Blue Coat was incorporated under the brand name of CacheFlow. Again, originally the focus of the company back in 1996 was to provide caching solutions to the service provider community to speed up the worldwide wait for the service providers. So that was the first problem that they had in the late 90s. The internet just came about, just came in vogue, and users were getting very poor response time. So by putting caching inside of their network, it improved the response time for the users. And that was really the first use case of caching, and we actually pioneered that in 1996 and in the late 90s. And by about 2002, 2003, that kind of went away. The pipes were big enough, the performance was good enough, and actually we have a lot of legacy CacheFlow boxes out there. They're the big yellow boxes. Some of you may have visibility to, some of you may not. But we have really good roots within caching. In terms of other things about Blue Coat, again, this is somewhat marketing stuff, but we've got 130 patents that we've issued, 60 are pending, and 19 specific to caching. So even when we actually got out of the original caching business in the early 2000s, that technology still lived within our standard web security products and our WAN optimization products. The technology never died. We've always kept it afloat within our other products. We never had it separated as a complete separate product. Okay? Corporate stability, just under $500 million in revenue, obviously plenty of cash. And probably about 3 years ago, our board of directors made a strategic decision that we were going to have 3 growth engines in the company. They saw an opportunity with the video tsunami, a lot of data growth, and the fact that we had the caching technology. They made a decision to get back into the web caching business. They built out a dedicated carrier class product division, sales division, marketing division, support division, focused solely on caching, and we aptly named it CacheFlow based on the rich heritage we had back in the day. We had a lot of good experience with the CacheFlow brand. It has a very strong brand, so we brought that brand back. Okay? So I think one more little trend chart that I want to show you, and this is really important because this kind of, I think, talks about how the web has evolved over the last 15 years and the fact that really making sure that you guys are planning for the future is critical. So The Web 1.0 era, late 1990s, information web, content was very static. You went onto your web page, you accessed your content. It was, again, very static content, not very dynamic. And the challenge there was to reduce the worldwide wait. And we had a solution that we called CacheFlow back in the late 90s. Today, we're in the Web 2.0 era. It's very collaborative, very dynamic. There's a lot of file sharing. There's a lot of video, a lot of dynamic content. The challenge is, how do you deliver all this rich multimedia content? How do you control peer-to-peer traffic? The solution that we focus on today is our new CacheFlow platform and the Packet Shaper product. And again, for those that some of you do know Packet Shaper, it's all about bandwidth management, rate limiting, being able to really get good control over certain applications within your network. I'm not going to spend a lot of time on this. Really, where I'm going to focus the balance of the presentation is on CacheFlow. So the Web 3.0 era, which is where we're coining the term, it's really kind of what's next? What's the next big thing on the internet? Who's going to deliver it? How is it going to be delivered? So this is what I talked about a little bit earlier. Today it's Netflix. 3 years ago it was YouTube. Also 3 years ago it was Facebook. Obviously they came onto the scene very quickly. There's going to be more that we have no visibility to today. So architecting the network and planning for whatever's happening in the future is going to be critical. And where Blue Coat actually adds some value is around something we call cache pulse that I'll get to in just a minute. And this is really being able to help you architect a network with web caching technology that remains current as the trends of the internet evolve over the coming years. All right. So now I'm going to talk just a little bit about the product itself. This is it's the CacheFlow 5000 platform. It's a dedicated carrier caching appliance built from the ground up, focused on the carrier market. Okay? And again, using a lot of our legacy technology. So it wasn't net new technology that we designed from the ground up. We took a lot of the technology we had, retooled it, and built out this platform. Again, the benefits are around bandwidth reduction at access points. We also have the ability to offer content filtering. So especially in the educational sector, we have a lot of customers using this technology, not only to deliver the benefits around web caching, but also being able to use the platform to deliver content filtering services, whether it's using Blue Coat's own filtering technology, blacklists, whitelists, watch foundation lists, being able to do some malware prevention and content filtering on this platform is another value-added benefit that this brings. Okay? This technology today is delivering, on average, about 1.5 gigabit of client-side throughput. All right? So again, it's a scalable platform for the internet service provider community. All right, come on, button. So some of the key differentiators, at least from the Blue Coat standpoint, obviously we have a rich history in caching, which I talked about. I think the key here is around really bandwidth saving. So it's one thing to state that you can save on bandwidth. The question really is, how much bandwidth can you save me? Our average bandwidth savings is roughly about 40% across the globe. Obviously, depending on where you reside, will depend upon your traffic types, which will dictate how much bandwidth savings you can achieve. So in the Middle East, for example, in Southeast Asia, we can achieve bandwidth savings pretty easily at about 50%. There's a lot of YouTube that's going on out there. We do an excellent job of caching YouTube. In the US, because it's very, very, very heavy Netflix users, we're seeing closer between 25 and 35%. And Netflix, for those that don't know, in terms of how you cache Netflix, because Netflix can be streamed from so many different devices at different bit rates, now you're talking about not one movie file to handle all those different devices. You actually need multiple video files that need to be cached depending on the actual device that you're serving it to. So you can't get as much caching efficiency with Netflix as you can, say, with a YouTube. A YouTube video is a YouTube video. You can cache it once and serve it to different devices regardless of the device. Okay? But for Netflix, it's a little bit unique, and that's what makes the bandwidth savings number come down just a little bit in the US and Canada, but we're still seeing between 25 and 35% bandwidth savings for both the US operators and Canadian operators. We have this thing called dedicated content caches, so we also have the capability to actually build out specific content caches. So for example, if you have a network where you have a lot of YouTube traffic, let's just arbitrarily say it's about 25% of your network traffic, you may want to dedicate a specific content cache just for YouTube. By building dedicated content caches, you can get better bandwidth savings up to about 90%. And that 90% number is typically for more of your semantic updates, AV updates, iOS updates, if you wanted to do dedicated content caching for that kind of content, because it is relatively static. And you can actually get a very good caching efficiency for that type of content. For YouTube caches, usually around 50% bandwidth savings. The other key differentiator is around web browsing performance. So Blue Coat's architecture is designed to support not only caching of large objects, but also caching of small objects. By being able to cache both large and small enables us to deliver better performance to the browser, because if you can only cache large objects well and not small objects, your performance is only good as the slowest point. So being able to cache both is really something unique that we can offer, and that's why we have a lot of customers looking at us solely for improving user experience. And then the last differentiator that I'll talk about is our CachePulse technology, which I'm going to get into right now. Okay. So CachePulse is something that Blue Coat coined. It's really an internal cloud-based service. So all of our CacheFlow appliances around the globe have a heartbeat that connect into our labs, which are actually here up in Waterloo, not too far from here. All right, we have a team of engineers that are monitoring all of our CacheFlow appliances around the globe. So the value that CachePulse really brings is it gets a lot of real-world data from the CacheFlow appliances that are communicating with it. If they identify a specific, let's say there's a type of video content that is getting very poor caching efficiency, but we feel that the caching efficiency should be much better, the engineering team that we have that's focused on this in Waterloo will actually real-time change the rules and algorithms of our caching algorithms within the boxes, make the changes in Waterloo, and we push those changes out through that heartbeat out to all of our CacheFlow appliances globally. So in real time, and it's transparent to the user, those devices remain up to speed and fully, in real time, keeping that high caching efficiency rate. Okay? This is something that's really unique to Blue Coat. This is where you may be able to get good bandwidth savings today, but 6 months from now, Google, which has a habit of changing their headers so that they make their content really tough to cache, we've got the engineers that understand how to actually change our algorithms to cache that content. So if you start off with bandwidth savings, let's say at 30%, it may drop to 25%, and once that drop happens, Blue Coat will get wind of that, our engineers will get wind of that, we'll make the changes to the caching algorithms, we'll push that back out to our global appliances, and that bandwidth savings will come back up to 30%. And it's a continuous feedback loop that we have between our CacheFlow appliances out in the field and our CachePulse service, which again, really is a team of engineers located in Waterloo that have IP connectivity out to each of our CacheFlow appliances. Okay? So this goes into it in a little more detail, but I'm going to spend a minute really on the right-hand side, and this is really more of kind of deployment and really best practices of deployment. So within a service provider network, you've got your access routers. Okay, we recommend actually turning on your policy-based routing to route all of your port 80 traffic into the caching farm. And this is an example where you've got multiple cache boxes. Depending on the size of your network, you may only need one box. You may not need multiple boxes. But just for argument's sake, let's state that this is going to be a larger type of web cache farm that you're going to build. You would divert all of your port 80 traffic through a policy-based route into the layer 4 switch, which load balances it across the CacheFlow appliances. Okay? If the content does not exist in the CacheFlow appliance originally, the request actually goes out to the internet, grabs the content, puts it on the CacheFlow device, serves it to the subscriber. The second time that content is requested, comes to the box, and it gets served from the box. And that's where you really get your bandwidth savings. In the example of a viral video from YouTube, if you didn't have caching in the network, and you had hundreds of subscribers accessing that same video content, every single request would go out to the internet, would grab the content and serve it back to the subscriber. Where caching adds the value and where the benefits come into play is once that first request comes in and it gets stored onto the CacheFlow or the caching device, it serves it immediately to those hundreds of subscribers. And that's where you get a lot of the bandwidth savings on the back end in terms of how you plan for your internet capacity and your growth for your, the internet capacity that you use with your upstream providers. Okay? This also gives kind of a graphical depiction of how CachePulse works. I'm not going to go into this in any more detail, but again, dynamic updates, optimizing bandwidth savings and user experience. Again, so as there's a lot of dynamic URLs out there where you've got multiple URLs that actually are accessing the same video content. we've got the techniques in place to actually adjust our algorithms, send them out to the CacheFlow devices so that we can actually know that that video is located on the CacheFlow device, and we'll serve it to the subscriber even if it's accessed through a different URL. Okay, and that's one of the use cases of CachePulse. All right. Any questions on CachePulse? Does it make sense to everybody?
I have a question.
Sure.
How is this different from a component network? And why should I have this instead of Akamai, for instance?
So that's a great question, and we get that question frequently. So Akamai, I would say about 75% of our installations are actually deployed alongside Akamai. Okay? Akamai and content delivery networks by default, what they do well is they've got relationships with content providers. So they're actually, Akamai is talking to the different content providers, and they're focusing on the static content. So your CNN, your ESPN, some of your AV updates, they are caching effectively static content. The dynamic content, the Netflix, the YouTubes, file sharing sites like Mega Upload, Rapid Share, they don't cache. And that's where CacheFlow complements a content delivery network. So what we're seeing in terms of percentages, so if you look at the port 80 traffic within any ISP's network, Akamai will typically serve between 10 to 20% of the traffic. So you still have about 80 to 90% of the traffic that's not being served by an Akamai CDN platform. And that's where transparent caching technologies such as the CacheFlow 5000 platform would actually complement Akamai.
Because you do that in real time. I mean, you're caching, and do you, do you know in real time what is the content that you have to cache, or there is a, my question is, let's say that I'm a service provider, and all of a sudden I realize that there is a particular film that is being streamed. Mm-hmm. Do you cache in?
So we don't do, I think the question is, do we actually prefetch and load the cache before an actual, like if a new video is coming out? And the answer is no. CDNs will do that for their content. They'll actually go out to the content origination source. They'll pull the content into the platform, if you will, and then as requests come in, they'll serve it. Our platform is different. Once a request comes in, we'll see if it's in our cache. If it's not in our cache, we grab it from the content origination source, we pull it into our device, and then we serve it. So it's a little bit of a different model.
But who initiates is it the user, or is it the...
So the user will let's use YouTube's the easiest one or let's use Netflix. Netflix I think is an even better one. So when the subscriber wants to access a Netflix video, as long as the service provider has turned on policy-based routing, they'll route that port 80 request directly to our box. We'll look in to see if we have that video asset in our box. If we don't have it, we actually go out to the origination source where that content resides. We'll pull that content in. We'll actually store it in our cache, and we'll serve it to that subscriber.
Okay. How many boxes do you have in a typical large ISP?
So as mentioned a little bit earlier, the CacheFlow 5000 can deliver 1.5 gig of client-side throughput. So in the university segment and the colleges, we typically see between 1 to 3 gig of total port 80 traffic, so which would constitute either 1 or 2 boxes. In Southeast Asia, where we actually have a lot of major large deployments, as well as the Middle East, we have deployments with 20, 30 boxes.
Do you have redundancy?
Typically not, because we're not in line. So we don't recommend redundancy unless you absolutely require redundancy. So looking at this picture, again, if one of the boxes goes down, the traffic just flows out to the internet. It's transparent. We're not in line. We're offline because of the way we set up the policy-based routing off of the access router. Okay. So it's an important question because we always get the question, well, CDNs are really providing the value that we need. But the reality is once you look under the covers and you look at exactly the content that the CDN is caching for you, the chances are it's probably around 15%, maybe 20% of the overall web traffic. There's still another 80 to 90% of web traffic that's not being cached. And that's where the benefits of transparent caching come into play. Now, we're also partnered up with a company called, you guys, I'm sure everybody knows Alcatel-Lucent. They have their own content delivery networking solution. They're actually a global reseller of our CacheFlow technology. So they've integrated that into their CDN platform. It's a little different than Akamai. They're going after a different segment of the market, which is really cable operators that want to build their own in-house content delivery networks to deliver video on demand services. That's kind of the market that they're really going after right now. Okay.
How does the device know if the content is updated? Is there a refresh? Does it refresh?
There is. There absolutely is. So I can't get into it with into too much technical detail, but there's a check between the CacheFlow 5000 and the OCS, the content origination source, on a regular basis to make sure that the content that's in the CacheFlow appliance is current.
We're talking about hours. We're talking about a day.
I believe it's done might be by the day. Yep. Okay. Any other questions on that?
It's just about the capacity, like inside the box is is it hard drive, how many hard drive?
Yep, so it's got 30 terabits of disk per box. Okay. Yep, and that's it. And it's got 10 gig interfaces as well as 1 gig of interfaces.
I have a question, it's a bit technical. You mentioned Alcatel-Lucent, and you said that they are going after the cable companies.
Mm-hmm.
The cable companies, what they have is video on demand, which is not necessarily video over IP. And the video on demand, very often they have like special boxes that, it's kind of simple switch. The way they provide video. So how do you integrate the two? I mean, the fact that because from what I'm seeing is it seems that your boxes are basically IP, whereas the cable companies they have, for the time being, they have a different technology.
So a lot of the cable companies, from what I've seen as well, are also IP. Now, in terms of integration, right now it's really more on the management side. We don't have a single platform where we've got devices that are integrated in terms of the hardware integration. It's mostly on the software side. Okay. All right, so let's keep moving. So this is another, I think, key feature that we have, something called cache review. So if you're an ISP and you have Blue Coat's CacheFlow appliance in your network and you notice that you're getting 30% bandwidth savings, and then all of a sudden one day you see that drop to 25%, and you recognize that there's a domain where the caching efficiency was high and then one day it was really low. This is where you would come, you would enter that URL in here to see if it's cache pulse enabled, okay? If it's not, our engineers in Waterloo get wind of it, we look at it, we actually dive into it to understand why the caching efficiency went down. We'll make the appropriate changes as need be, and we'll push those updates back out. So this is really a feedback loop for our customers to communicate with us on what content was getting good caching efficiency, that's no longer getting good cache efficiency, or content that's just not getting good cache efficiency, and they want to see if we can provide some additional algorithms to improve the caching efficiency of that content.
I'm just thinking that static sites would apply, caching would be valuable in those sites, but as we go along, I guess the more we move on, the less static information we've got out there. And I'm just thinking of sites that would provide streams of live covering of different events, or how would the box handle such sites?
So today, the box does not support live streaming.
So there's no caching basically for CNN or Radio Canada?
Well, if it's actually live, we don't cache it. If it's video on demand, which CNN.com has lots of videos on the website that are viewed on demand, then yes, we would cache. We cache those video assets, absolutely. Does that answer your question?
Well, I guess some of the sites would be covered in the cache, and other components of the site would be actually...
It depends on how it's being delivered, but for live streams, if it's really a live stream, we don't touch the live stream. If on CNN.com there's a major event, there's a death of somebody very prestigious,
Thinking of 9/11, for instance.
Mm-hmm.
Obviously, most of us experience traffic on the internet was, well, mind you, if I cache here, it wouldn't provide me much. The rest of the world doesn't cache.
Mm-hmm. But that's a good example. So when you have a viral event, Michael Jackson's death, even Gaddafi's death, you're seeing networks getting taxed because people want to watch the video, they want to see the pictures. Those aren't live streams. Those are pre-recorded that have been hosted on that content provider's site. And that's a perfect example of where caching adds value, where there's thousands and thousands and thousands of people accessing that video content. So here's a great example. It's feasible that somewhere in Canada, the first person looked at that video file, wanted to see it. The second person came, wanted to see it, and we got wind that we couldn't cache that. Okay, so that raises a flag. Our Cache Pulse team conceptually will get visibility to that video not being cached. We'll quickly update the rules and push those out to our global appliances to make sure that we can cache that. Now, not all content is cacheable. We're not saying that we can cache everything, but there is content out there that today is not cacheable that very well should be cacheable.
How about Netflix? I mean, you have video on demand that is for a long time. So if you want to, I come back to the cable companies. They want to watch a film. Maybe they want to watch a 30-minute HD or something. Do you cache that or not?
So it depends on the video. So when we're talking port 80 HTTP, we'll cache it. When you're talking about video on demand service for a cable operator where they're pre-populating content, probably movies from the movie studios, we don't touch that content. Not at all.
Okay, but then what is, that you said that you work with Alcatel?
Yeah, the tie-in is that they complement one another. Okay, so when you think of being a service provider, you want to control all of the content on your network, regardless of what type of content it is. So you've got content that is video on demand content that might be an Alcatel-Lucent platform, and then you have everything else that's what we would classify as unmanaged over-the-top content that an Alcatel-Lucent platform will not address. So being able to have a complete management umbrella to control all of your content and improve quality experience on all of your content, that's where those integration points become valuable. Does that make sense? Okay. All right, so let's keep moving. This is just an example from, I think, one of our operators out in EMEA or out in the Middle East. The top blue line shows the client-side throughput for our CacheFlow 5000 appliance. So you can see in this case, we actually got over 2 gig in client-side throughput. And when I say client-side throughput, I'm talking about serving content to the subscriber. So that one box can serve, on average 1.5, but even during peak times above 1.5. We got up to about 2.4 or 5 here. The green bar shows the content that actually left the operator's network. And it's the difference that really articulates the benefits or the bandwidth savings that our CacheFlow appliance delivered. So on average, we were delivering 1.6 gig of client-side. 850 of that was actually leaving the network for an average bandwidth savings of 47%. Okay, so this is just, I think, a proof point of CacheFlow, Cache Pulse in action, and the type of bandwidth savings benefits that one of our operators is experiencing. Okay. All right, so I'm going to run through these pretty quickly. We did some of our own independent testing, and when you're looking at user experience, there's obviously a lot of variables that come into play in terms of improving the internet experience. Caching is one area that can certainly help, but it depends on really what the problem is if you're having a problem around user experience. But what we've seen in just some of the basic testing that we did of some large objects, both with CacheFlow and without CacheFlow, this is the difference in response time. So YouTube, obviously much better improvement in response time for YouTube. Dailymotion is a file sharing site. Facebook video, and MySpace. Okay. And then the next chart is small objects. So again, you can't have a improved user experience solution without being able to cache both large and small objects. And when you go on your mobile device, as you're looking at the mobile device and you're pulling up a video, you'll see that there's going to be two streams. One is going to be for the object, and one is going to be for the web content. And you need to have both of those come to the device in order to have better user experience, which is why it's so important to cache not only large objects, but also small objects. And again, we just took a snapshot of a couple of the more well-known sites, more heavily trafficked sites, and the difference in response time for these small objects. Okay. The last use case that I talked about was reporting and web analytics. So within, on the box, we have reports that are focused around bandwidth savings, content cacheability, and web traffic patterns. And you can look at those by hour. You can look at those by day. And I'll show you really quickly what those look like. We'll go through this quickly. So this chart, and again, this is a graphic that comes right off the box, shows the bandwidth savings for the different domains. Okay? So on the bottom lists all the domains and the bandwidth savings. You may see bandwidth savings that's 0. The reason it's 0 is somebody requested that content, and no one else came and requested that same content. So you're not going to get any bandwidth savings. For something where you get a lot of bandwidth savings, Microsoft.com, it's 100%, meaning multiple people have accessed it, and we've got good caching efficiency for that particular domain. Okay. The next is cacheability. So this shows you what content actually is cacheable. So by domain on the bottom, okay, summarizing exactly what content is cacheable. And this is where cache review comes into play. If you notice, let's say YouTube is at 100%, and one day it drops down to 50%. That's a flag. Send that into our cache review. We'll look at it, because it means that the caching efficiency came down, which means that YouTube is probably doing something a little funky. We got to make some changes, push those out through our cache pulse, out to your appliances to get that caching efficiency back to 100%. Okay? And then last is web traffic. Again, being able to look at a pie graph that shows by domain the usage for your subscriber base or your user base. Okay? And all of this can be reported on, again, by day or by hour. Okay? Any questions on the reporting? I think it's pretty self-explanatory, but any questions at all? All right, let's keep moving. So this is really the last thing I'm going to get into today, which is around content filtering. I talked about some of the use cases of web caching, around bandwidth savings, around user experience, around reporting. Another benefit that really goes beyond what I just talked about is content filtering. So some use cases, some of the educational facilities are very interested in using this for filtering their content for faculty and for staff, so that they don't look at adult video or they don't do gambling. And there's a lot of different categories and ways to filter content. This platform can host a number of different databases, including the Blue Coat web filter software, as well as custom black and allow lists, as well as something we call Internet Watch Foundation, which we see more in EMEA and APAC. The other use cases around malware. So some of the ISPs that we're working with are actually using this as a means to provide a malware solution for their subscriber base. There's a lot of malware out on the internet, and being able to have an ISP service that's clean pipe, if you will, where your users are not allowed to access sites that are malware is a benefit that many ISPs are utilizing today with the content filtering capabilities on our appliance. All right. So these are just a cross-section of some of the customers around the globe of our CacheFlow product. Okay, you could see a lot. I mean, you may not recognize a lot of these names. Again, a lot of them are in EMEA and Southeast Asia.
Moving back to the previous slide, how much flexibility have you got when you're managing that box in order to deal with this content? Like, having looked at different products on the market. Some will allow you to, inform the user that he's actually not complying. Like, we're not blocking it, but we inform the user by entering that site. You go against the politics of our organization, whatever. Be aware, or they may tag them. There's various options basically, but as far as this box is concerned, is it just blocking or informing?
So really, there's an exception page that you can set up, and that exception page will actually report back when they click on that URL. The page flashes up, and it's really, you can custom tune it however you want to write it. But it's not based on individual IP. Okay, so Blue Coat has been leaders in content filtering. We've got other platforms where you can get very granular at an IP level, at a user level, report on that user, and actually provide the type of I think information that you would need to report back to that HR department, legal department, to state this individual user is accessing this content illegally. Let's send a notice out to him or This particular box, the CacheFlow box, can do the content filtering, but it's done on a range of IP addresses. So it can provide really a filtering policy over a range of IP addresses. It really doesn't get that granular at an IP level. Okay, so you're not getting as rich granular policy controls compared to, and reporting as well, compared to our Proxy SG platform, which is our flagship kind of secure web gateway platform.
What does exactly the filter do?
So for example, I'll give you a good use case of several ISPs in the US that will deploy the web caching technology within their network. And they have two subscriber bases. They've got individual subscribers like you and I, and then they have an education, K through 12. They want to provide, they cannot filter their subscribers, or they choose typically not to filter their subscribers. Maybe they'll do malware, but in this example, they didn't. But they want to filter K through 12. They don't want to have them access to any adult content. They don't want to have access to gambling sites. They can set up a policy for all the users on that K through 12 network so that they can only access certain content. And that's really the key use case that we've seen with the utilizing the web filtering technology. Okay? Does that answer your question? Great. Okay. So again, the customer list. And then this is really the last slide. So I think the customer probably most appropriate is Queen's University. Some of you may know them. They're out in Ontario. They're one of the early users. So let me just take a step back. I mentioned that our caching technology, we have a lot of customers in EMEA. We have a lot of customers in Southeast Asia. We haven't spent a lot of time in the US and Canada pushing this technology, to be very frank. It's been about 9 months. Queen's University, and that's just from a resource standpoint, we saw that the highest bandwidth costs across the globe are in Southeast Asia and the Middle East. What we've recognized here in the US and Canada is there are actually places that have very high bandwidth costs. And what we also recognize is we have a platform that delivers very good quality of experience. So we're now starting to move more aggressively into these markets, to be very transparent. Queen's University was one of the first users that actually utilized our CacheFlow technology. And this is really around bandwidth savings, as well as, to some extent, from what I've heard, improving user experience. But a lot of it was around bandwidth savings. That was the primary use case here. Just one other data point, one other use case that we're seeing for universities in the US. There's a lot of textbooks coming online. I don't know if you're seeing that as a similar trend here in Canada. We're seeing that trend in the US. We've got several universities that are utilizing caching and really replacing some existing caching technology that we use to cache those online textbooks. That's a prime example of you've got a big user community of students that are accessing the same content, whether it's for class, for an exam. A lot of it is video content, and being able to actually cache that on the network and not have to go out to get that content every single time, there's tremendous amount of bandwidth savings. And you can get very, very high bandwidth savings because there's a lot of people accessing the same exact content. So that's just another use case we've seen within the public sector, or the educational sector, I should say. Okay? And that's really it. I think the summary is networks are being taxed more than ever, as far as the trends that we talked about. A lot of video content, and that's going to continue to explode. Video growth, I wouldn't really say it's in its infancy, but it's growing pretty fast. And there's still going to be, as more mobile devices come out, you're going to see a lot more congestion in the network. Transparent caching is back, for really the focus around bandwidth savings, improving user experience, and to a lesser extent reporting. And that's really it. So I'll open it up to any last questions that anybody has.
I'm just curious if you had made some calculation as to where does a client come, or when does it come to a client, comparing how much you pay for your internet traffic, where our box or our solution becomes worth the value, basically.
I think that's a good question. So if you're looking at web caching in the context of bandwidth savings as being the primary use case, and that's it, forget about everything else that I talked about. If that's really what the focus is, really the barometer is around $15 to $20 per megabit per second per month. Okay, that's usually the threshold. If you're well below that, the ROI for caching is...
includes the maintenance
Everything, yep. Now, the one point that I will make that's really important, some of the use cases we're seeing in the US, people are paying $5 per megabit per second per month, but they're in a 1 gig infrastructure, and they're in the process of deciding, do we go to 10 gig? And if we go to 10 gig, the costs, the CapEx and OpEx associated with going from a 1 gig infrastructure to 10 gig is enormous. So there's a huge use case to put caching in to delay that infrastructure upgrade, in some cases for 18 to 24 months, and then caching pays for itself within probably 6 months. So there's other variables beyond just that 1 bandwidth per second per month. There's other metrics and there's other variables that you need to look at to gauge if there's value or not. Okay? All right, guys, I think that's a wrap, unless there's any other questions. Great. Well, thank you for hanging in there. I know it's late in the day. I appreciate it, guys. Thank you and gals.